Hey, do you want to learn how to get started with embedded Swift? In this video, we are going to dive deep. I have no idea if this is going to work. I just got this little microcontroller. I don't know anything about embedded development, but I thought it would be cool. My dad's been doing some of this with his ham radio. Hey, what's up? This is Paul Solt, and let's get started. So I got the SparkFun Thing Plus ESP32-C6, and it's supposed to have support for HomeKit. Now, Apple demoed a different one. I didn't get that one. They got the Espressif, which I think this has the same chip, but it's just a different manufacturer. This is from SparkFun. I'm hoping we can figure out how to get this to work. Otherwise, I'm going to have to buy the other thing that Apple demoed and see if we can connect it. So with this, we should be able to, I got the one that's got the USB-C. I should just be able to connect it on USB-C, and we're going to see that it lights up. Mac is going to ask about doing stuff with it. It's already going through a color program where it is running a color and it's changing this RGB LED that's on here. This is a status LED. I see there's a power light and then there is a charge light, but there's nothing charging because there's no battery connected. So we're going to see if we can connect to this over USB. I'm going to hit allow, and then I'm just going to open up a new window here. And let's make this bigger so we can actually see what's going on. And then it's going to be dev, and I think it's cu.star. And we should, maybe it's not that. We may or may not see it connected here. I'm expecting to see some kind of USB. I don't know what I'm looking for, to be honest. I don't know if they install drivers. Just a quick little look to sort of see what's there. Okay. We're going to follow along with Apple's guide. There's a lot of different things that I'm going to be showcasing, but the first one is this link, Introducing Swift Matter Examples, which introduces how to do stuff with Swift Matter so that I can do HomeKit stuff. I use HomeKit on my iPhone right now. So if you have an iPhone, I have this hooked up so that I've got all these settings to control my garage and my locks on my house. So I can control them from up here. I can open all the garage doors. I can close all the garage doors. And it's super awesome. So I thought if I get one of these kits, I can at least play around with it. I have no idea what I'd do except maybe automate like watering of a garden. That's like my only idea I've got sort of running through my head. But I wanted to see how I could get Swift to run. So let's get started with that. We're going to follow their guide. So you can watch their video and they'll talk about like all the different things that it allows. There's a subset of Swift. This is experimental. It's not all functional. You are going to need Wi-Fi, HomePod, Apple TV, and iPhone. I think you need either a HomePod or Apple TV to serve as the HomeKit access points. And then we're going to be talking to this little microchip. From the Mac, we'll be able to write some code and change the color. And then there's some other things that they talk about. So right now they're supporting 32-bit and 64-bit ARM and RISC-V chips. And I believe this SparkFun is in a RISC chip. So this is a RISC-V. I don't know like how fast it is. Like it doesn't have that in the specs here. I'm just hoping that we can get it to compile. So these are the Swift Matter example tutorials. Now I have a link for this in my notes down here so that you can get access to this. We're going to get started. So we need these different things and we're going to have to install those. I haven't installed any of this yet. So we're going to learn how to do that as we get started with this. Now, there's a few different sections. There's this Docker thing. I think I can skip it. I think that's for like simulating a Matter thing. So we're just going to get started with Mac OS. It says it's going to take 30 minutes. Let's see how quickly we can do this. All right, so I've got Xcode installed. I've got the beta. I don't know if that matters. Then I need the nightly toolchain. Okay, so let's see if we can download this. I'm going to open this up in a separate window. Bring this over here. And we lost our directions. Okay, so trunk development main, Xcode universal. Are they saying that I need Swift 6? Like, I'm a little confused. There's Swift 5.10. I'm assuming I can't use that, but honestly, I have no idea. And then down here, trunk. Oh, is this, did they say trunk main? So this is like top of tree. Is that what this is? So we got Swift 5.10. These aren't official releases, so we need to use trunk main. So I might run into issues being on the trunk because it's not a valid release. Okay, because this is not in the main line, I'm assuming. Okay, so then we're going to scroll down to Xcode Universal. I've never done this before, so let's go to Universal. Talking about Docker tags. Okay. So I think we just click this, download this. Once we get that, I have no idea how long this is going to take. Like, what are we downloading? 1.47 gigabytes. So that's going to take a little bit of time. Hopefully my Ethernet connection is helping us get a little bit more speed, but it doesn't look like it's super fast. Okay, so once we get that, we're going to get this package, 1.47 gigabytes. We open and install that for all users. It might require a password prompt, and then we're going to startup.shell. Okay, so it's going to tell us it's going to install it in library developer toolchain, and that's exactly where I want it. Yeah, so I want it in the root right here. Just copy that just in case. Okay, so now that it's downloaded, let's click on it and let's continue. Install for all users. Install 5 gigabytes. Wow. I need my password. I can't use Touch ID. Okay, we'll bring our terminal window back. And I'm just going to pull this. No. Did I do this wrong? Just going to hide this. We're just going to focus on this. I think that's pretty readable. Okay, so installation was successful. Let's move it to the trash. Don't need that anymore. Okay, so now they want me to do ls, and then it's the path that I copied. So I copied this. And now what? So that's a 6.4. I've got the 7.15 top of tree or whatever. XC toolchain. So we see the XC toolchain, which is this file right here. And then we're going to find the identifier with the plutil command to record the printed identifier. Okay, so to do this, I'm going to have to type all of this plus this to get this value. So PL util extract CF bundle identifier raw. Is there a reason I have to do this over multiple lines? Why can't I just type it out? So then let's type in that path and then Swift development snapshot toolchain. And then info.plist. Like, why can't I just open the plist? We could just open the plist, right? They want this. I don't know why. Okay. Sure, we can do it with a command. I had to update the command so that it would work because it was not set up for what I was doing. So I'm just going to keep a running tally of all the stuff that we're doing here because my stuff's differing a little bit from what they're suggesting. I'll just put this here because I have no idea what we're doing here. All right, so we just determined that we have this value. I don't know why they split it up over multiple lines. And so once we get that, I'm creating a variable. I'm creating an environment variable. And then I'm running the Swift version and trying to verify that that works. Okay. So I'm going to say tool chains equals this value that we just copied. So mine's a little bit different from theirs because it's a newer version. Swift, and yours is going to be different every time you run this. So it looks like Swift itself is looking at tool chains and environment variable. Let's move this up here since my face is probably covering that, and we'll put my notes down right here. Let's go up top. Okay, so we see we've got the 6.0 dev. So this is a 6 version. We got the LLVM, we got the Swift version, we've got the target is going to be ARM64. Great. Okay, so next up, we need to install the ESP IDF. I think this is their development environment. And then the Matter SDK, which is, I think, really big. That's like 15 gigabytes. Okay, so they're going to provide some setup details, but we potentially need to go in here to these 2 links to do the setup if this doesn't work. So if you don't have Homebrew set up, you need to install Homebrew. And that's going to be this command. Homebrew is this it? It's brew.sh. So this is Homebrew. That command that they're linking is just the command that is here that you can copy to your keyboard and just run. And so I already have Homebrew. It probably would want to be updated at some point, but I'm not super concerned about that. And so we're going to use brew to install ESP SDK dependencies, CMake, Ninja, and DFU util. So let's go ahead and copy this. And I have to do Control D. Okay. I'm going to have to type this because it just copied things. I think I might have CMake, but I don't know. I don't on this new machine unless it carried over. I definitely don't have Ninja or DF util. So let's brew install these. I guess it did update Homebrew. Now it's updating CMake, Ninja, DFUtil, upgrading CMake. Okay, CMake was already installed, so it's updating that. And now it is finished. So one step closer. And then they want me to make an ESP directory. So let's go ahead and make a directory. And I think the -p will just create it. So we can then cd into ESP. And you'll see this is in our home directory. Okay, so they move into that, then they clone. Like, I don't know why we're separating this over so many different lines. I guess I can copy it this way. I think there's a newer version. When I was looking at ESP, I have so many links. So there's a 522. I don't know if that makes a difference. If I do edit on GitHub, what does that do? I want to go to releases. That's all in 522. That's a lot of things. All right, so they have this. Is that the same type of command? No, it's slightly different. I don't know what this is all doing. So let's just copy this. Let's just, for kicks, try this version. I think this is 1.5 gigabytes or 500 megabytes. I don't know what get depth meaning. So that's supposed to make it a little bit smaller, it looks like. And then I don't know, shallow submodules. Okay, so that finished. Let's jump back to the tutorial. Okay, so then we want to run the install script. So we're going to see a bunch of stuff in here, and we're just going to do .install.sh. It detects that I have Python 3. And while that's working, I'm just going to resize this window. Okay, there's a 1.3, and this tutorial was written against 1.2. Oh, so they're recommending the other one. So we might want to grab the other one. I don't know. We'll give it a try still. So we're just going to run this command. They don't actually have any releases. Or there's probably just, I don't know anything about this. There's probably just different specifications. Okay. So we'll come back here. And it looks like this is going to take a while. I'm at 13%. And then we have another install script that we're going to run once this finishes. After that, we're going to set up our shell environment. And then we're done. Okay, so while this is downloading, I'm going to get more water. And I'll be back in a minute. So in terms of embedded Swift, there's going to be certain trade-offs when working with embedded Swift. So it's great for producing small and freestanding binaries with no dependencies. Embedded Swift is not a complete one-click solution to program all of the embedded boards and MCUs. So it's part of the equation, but it's, I think, a complicated tool chain so that you have these other things that they're talking about, like all the stuff that we're installing. And embedded Swift is a compilation model that is analogous to the traditional C compiler in the sense that the compiler produces an object file, a .o file, that can be simply linked with your existing code, and it's not going to require you to port any libraries or runtimes. And then embedded Swift is not a HAL. It's not an SDK for development, and it's not a set of libraries or program peripherals using high-level APIs. Instead, it's a compilation mode that is suitable for creating these components. I don't know what a HAL is. Yeah, fictional character, sure. All right, so the typical setup is going to involve getting an SDK with the C compilers, headers, and libraries for the target. So that's kind of what we're doing right now. And then we're going to be installing this, which is going to do some of this step. Then we're going to link all the libraries and the Swift object files. And then we're going to format that into a firmware that we can then flash on the actual embedded chip that I've got here. Bring that closer. So there's a little microcontroller on this guy, and we want to be able to give it a new program to run. Right now it's running a simple program that it came with, but we want to be able to control that from Swift. And then we are going to upload the flashable binary to the board over a USB cable using the same tool. And then we'll restart the board. And be able to run it. And let's see if we can get this to compile while we wait. We're still waiting. Yep. So I'm going to do vi hello.swift. And then in here, we're just going to do print hello embedded world. Escape, exit that. We're going to do xc run swift c hello.swift. Enable experimental feature embedded WMO. And while that's thinking, we'll go back here. We're still unpacking that. I spelled that wrong. WMO. I'm wondering if this is because my toolchain isn't set up entirely. I don't know. Somewhere I saw, oh, maybe it's in the vision document. Let's go back and just see how we're doing. So this is for platforms that have limited memory. So we got microcontrollers or embedded systems. So like these are popular MCU boards, and they have much less memory than a traditional desktop or even iPhone. And environments where okay. So this is kind of a diagram of what embedded Swift looks like, but this is all experimental. And desktop Swift, whoops, whoa, don't do that. Desktop Swift is what we're used to. It's, I guess, 5,000 kilobytes. Statically linked Swift is smaller. It's half the size. No ABI stability, no dynamic loading. And then I don't know what this LTO-based hermetic seal model. That's smaller. Then there's something they might want to have somewhere in between. And then embedded Swift is down here, and they're saying it's 10 kilobytes. So I don't know if we're actually down there. So they want to eliminate large code saves cost of entry. They want to simplify the code generated by the compiler. They want to allow the effective, intuitive dead code stripping on application. They want to support environments with and without a dynamic heap. They want to remove or reduce the amount of implicit runtime calls. They want to introduce the way of producing minimal statical link binaries, and then they want to define a language subset, not a dialect. So it should be close to full Swift, but not the same. Some meta types are restricted. They're saying the standard print function in its current form is not available, and an alternative will be provided. There's no Objective-C interop, though C and C++ interop is not affected. Reflection and mirrors APIs are not available. Existentials and dynamic downcasting of existentials is disallowed. So you can't use the any. I still don't understand all of what that that means. None of these are okay, which is fine. We're still receiving objects. Types of thrown errors is restricted. Classes have restrictions. They cannot have a non-final generic function. So this is okay. This is not okay. They're not sure if they want to have meta types. Key paths are restricted. So Unicode data tables are going to be restricted. It's going to be an opt-in. So I'll have UTF-8. Oh, there's a non-allocating embedded Swift. Did I read that in this one? I didn't see that up there. Can't make classes. Oh, that's weird. Yeah, so I'm not exactly sure what this is. So let's see if we can Google this. Do I need to have this look at my tool chain? Is like that the problem? Did that work? Okay, so where were we with this tutorial? We were looking at here, and we were just trying to follow along with this one example. So at this point, we see we have a hello executable. So let's try and run it. Boom. Okay, so it looks like I just needed to update so that was just hello.swift, and then we just added that print statement. Which was this. So I think the toolchain was just the missing piece there. And what was the error that we got? It took over my whole output. I think I copied it. Still receiving stuff. All right, so that's our first, and let's take a look at how big that is. So it's 40 kilobytes. Am I reading this correctly? 41 kilobytes. And if I made that same thing in like Xcode, or just built without that call, let's just get rid of all of this. Okay, I don't know. That's even big, even smaller. Oh, is that with, because it's not experimental? but one of these is linking to the built-in system Swift, and the other one's got Swift embedded. Is that what I'm understanding? So this is just a much bigger executable, but it's still also linking to the Swift library somewhere else. Okay, I think we finally have this done. So now let's jump on over. And what we have to do is run the installer, which is if we just go back into ESP Matter, we're just going to do .install.sh. Okay, yeah, I'm going to want to put this in my ZSH file as the next step. So let's open that up. So I'm going to use TextMate to open up my ZSH file, but you can use whatever editor that you want to. And then in here, we're just going to add this tool chain. So I'll just copy this and we'll paste it somewhere in here. Just put it under my fast lane stuff. So what I'm going to do is just have that. So this is the Swift nightly toolchain. I've got one toolchain installed. I assume if I change the toolchain, I'm going to have to change this to point to the latest. And then do I want to add all of this to my? I don't know what the other ones are going to do, so I'm a little hesitant to do that. I mean, we could just do this when we're, I don't know. Let's just figure out what we're doing. And this is my Z. Let's just run this. So we're just going to do ESP IDF export.sh. Am I going to have to wait each time I want to do this? And I would have to reload my ZSH file if I put that in there. Okay, so that's that one. And then we potentially want to set this one up. I'm just a little unclear if these are always going to run or if this is just like a one-time thing. Because this makes it sound like it's already doing this. Because it just installed that tool. And so then let's go ahead and run this other one. Okay. So after that, how do we know if it's set up? Okay, so I think that's started. I don't think I need the Docker. I want to just run the example now. Okay. Oh, I don't know. This might be the only one that's set up now since I... Okay. I have a dev folder that I'm going to CD into. And we're just going to clone this. Okay, then we're going to CD into Swift Matter Examples, LED Blink. And then we'll use that command that we just installed, idf.py. We'll set the target. Since I've got the ESP32-C6, that's what this board is that I've got. I will use that. And we'll cross our fingers. So this is going to do some stuff. I believe I can do the same type of thing if I install a plugin for VS Code. So it did a configuration in 62 seconds. I think that first one's going to be slow or something. And I think after that, maybe it gets faster. Let's do IDF Pi build. Or maybe this is the slow one. Maybe they're both slow. So this is building 1,200 files. So this is going to start up IDF. I don't know what IDF is. That's IoT Development Framework. So that's part of Espressif Systems, and they're the manufacturer of the ESP32, which is on this chip. Got it. So I'm assuming, okay, so then we're going to load up the flash monitor. And this is going to allow us to see it's going to have a log. Okay, we're at 1,100 elements in this bootloader. Yeah, I think this takes longer than 30 minutes. I think this is like an hour plus. I guess we're in the second tutorial. This is 10 minutes. That first one definitely takes longer if you don't have it set up. Okay, and then to exit, we're going to do control and then the right bracket. If this finishes. And if this fails, we might have to go back a version. Okay, so now it's telling us it successfully created the ESP32-C6 image. Project build complete. To run it, do this flash or port and flash, or this Or I guess there's a lot of options for doing it. So this is going to simplify some of this, I'm assuming. So let's run this command. What was that last command that I ran? I did this. Just built that, so that took a little bit of time. And now we're going to try and flash. So I'm assuming now once it flashes this, the application is going to run differently at some point. Did I do it wrong? Oh, I didn't turn on the monitor. Okay, so it's doing something, and I'm trying to understand what it's doing. Okay, so let's go into my dev folder. We'll go into embedded, Swift matter examples, LED blink, and I guess that's just open this. A lot of stuff in there. We've got a bridging header. Okay. So we're seeing this. I am not sure. My LED is no longer blinking. If I save this, I'm wondering if I'm supposed to do something. let's go back and let's look at what's going on here. Initializing light driver and then setting LED set to these different colors. Oh, and then we're getting some kind of panic abort. Something to me doesn't look right. So we got it. It's working. It's just not blinking. Something doesn't appear to be right with how it is maybe setting these colors. So let's wait on that. And let's try and recompile this. So to do that, do I have to build it again? And then flash monitor. At least it didn't kernel panic right now. There is a IDF visual code. Okay, so that's installed. And then we can set TTY USB. I wonder if I can see that now. Before I couldn't see that. So if I do ls dev tty dot star or star. I don't know what this enables, but that's just one way to look at this. Okay, so I think the step is we've got to build it and then we've got to flash it each time we want to run it. That was much faster. So I lowered the intensity of the red, but it's not. It's not changing the other LED. I'm wondering if it's changing the wrong LED. I don't know what 20 will do. So let's try that. Try one more build and then I think we'll just wrap up for this video since we got something working. So this is what it looks like. I'm not seeing red, so I think something is not configured properly on that main LED that was changing color, and I'll just have to debug that a little bit more. And then do a follow-up once I figure all of that out and make a new video. Thanks for watching. If this was interesting, hit the like button and then subscribe if you want to get more tutorials on Swift. I'm going to play around a little bit more with Swift Embedded, but my focus is mostly on iOS and macOS apps. I was just curious of like, how could I get started with this? And then kind of what can I do with it? So if you have any comments, comment down below. I have no idea what I'm doing with hardware development. This is all new to me. I did a bunch of debugging with GoPro and dealing with real hardware, but I was not writing any of the firmware. So that was all like C code, I think, on our firmware team. And I didn't have access to any of that. So I just was a consumer of the firmware through the iOS app and our SDKs. I'll see you in the next video. Thanks for watching.